And I'm going to be explaining the model. So for model 1, we start with the ramp starting at 14 inches, and then it descends to the hill, and then heading to the curve, and then into a funnel. Then it goes into the catcher. We put things in this order to make sure that there was enough GPE, gravitational potential energy, to make it through the whole course. As the marble descends onto the ramp, the GPE changes to kinetic energy, giving the marble lots of speed so that it can make it up the hill. So here it needs to have enough energy to go into the funnel, so that it can make it up the hill. After that, the funnel slows down the marble so it can land in the catcher. When starting at the ramp, it's at its most GPE and least kinetic energy. When it's going down the ramp, it loses GPE while gaining kinetic energy. Going up the hill, it loses kinetic energy but gains potential energy at the end.
Okay, so I'm going to be explaining the law of conservation. So the law of conservation of energy states that energy cannot be created or destroyed, but it can only be transformed. Some energy changes to thermal, and energy changes from GPE to KE, and from KE to GPE. But the total energy must stay the same in the system.
Hi, my name is Amelia, and I'll be explaining the force. The force that causes the marble to slow down is friction. Two sources of friction are the ramp and air that acts on the marble. The force of the walls of the catcher causes it to fully stop. Air resistance is used when the marble rolls through the track, pushing air molecules out of the way, creating a resistance force, making the marble slow down. The main source of friction is the constant rolling of the marble on the ramp and track. The walls of the catcher exert impact force, causing the marble to fully stop.
Hi, my name is Adele Yule, and I'll be explaining the scale factor. So this is the graph that we drew, and this graph shows 2 centimeters of the real model, which is equal to 1 centimeter of the drawing, which makes the scale factor 1/2. After, another example is that this equals this, but what we did is that we did, this is half the height of the actual roller coaster, so that's why the scale factor would be
1/2. changes that we did in Model 2. So in Model 2, we added this piece of paper to make it taller and so it can have more kinetic energy going into the funnel. And then we also moved the funnel closer to the catcher so it doesn't so the marble doesn't fall to the sides.
Hi, my name is Adele Yule, and I'll be stating the speed and how much faster it went the first time and the second time and the differences. So after making the adjustments by hiring this pole, putting this closer and making this larger, we measured the speed and the average speed was 1.21 seconds and the average speed without all of these adjustments was 1.65 seconds. On average, the speed went 0.437 seconds faster than the first time. So this was a big improvement and therefore it shows that how much these adjustments improved the roller coaster.